Welcome back to True North Mechatronics. In our last episode, we designed the side panels for our Vetronics Enclosure. In this episode, we will bridge those panels together to create a rigid, unified structure with the top cover. We will utilize the same rectangular tab and socket interlocking technique that we used with the battery box. By designing this cover to physically interlock with the side panels and securing it using the corner anchors we added to the corners of these panels, we will ensure the entire assembly cannot pull apart under stress. Design, engineer, deploy. Let's get to the CAD. Begin by creating a new body and a new sketch on the XY plane. We're going to use the polyline tool, and we're going to sketch out a feature that includes the 3 tabs that we're going to use for one side of the enclosure. We're going to have to go back and modify the horizontal and vertical constraints here in a minute, but I'm going to bring it down. It's going to look like this. I'm going to move back over here to the other side. I'm going to bring this right down to the x-axis and over. All right, we'll close this off with an arc after we cleaned up the line segments that we created. So that should do the job there. Okay, and as always, let's set our tabs so that they are the same width. And we'll set the sides so that they are of equal height. We'll make the center tab so that it's symmetric around the y-axis. And now we're going to set some equalities here. So let's set the distance in between these two sets of tabs so that they're the same. And we're going to set that distance to 22 millimeters. Set the width of the... I'm actually going to clear away some of these constraints just to clean this up a little bit here. So bring that back. So there we go. So let's set the width of the tab to 10 millimeters. Let's set the height of the tab to 3 millimeters. All right, and so now we can refine the shape a little bit. Okay, I'm going to set the length of these two segments on either side of our outside tabs so that they are equal. And I'm specifically going to set the length of that to 9 millimeters. All right, so next thing that we're going to do is we're going to set the length of this segment here. So let's set that to 47 millimeters. We can set the height of this feature here at 11.5 millimeters. All right, now let's clean this up here a little bit. Let's set the vertical length of this to 44 millimeters. All right, and now let's set this segment to 27 millimeters. This piece here we're going to set to 14.5 millimeters. And now we can close this line segment here with the arc. So let's grab the Create Arc by 3 Points tool. Let's left click on those two segments there. And we're going to constrain the radius of this arc to 18 millimeters. All right, so this is 1/2 of the top for the Vetronics Enclosure. It's fully constrained, so let's close out of the Sketcher workbench now. And we're going to pad this feature out to 3 millimeters. Now we're going to add the mounting bosses for this to the top of our enclosure here. So let's create a new sketch in the top. We're going to reference these left and right hand edges. Let's grab the rectangle tool, and we're going to create 2 features here. We're going to make them so that they are both the same length and both the same height. Let's try that again. There we go. And the horizontal distance will be 8 millimeters. And we will make its vertical dimension 5 millimeters. This is the same dimensions that we used for the mounting bosses on the top of the battery box. All right, so both of these are constraints. We can close out of this, and we're going to pad these features out to 5 millimeters. And now we need to create the anchor points that our side panels are going to attach to. So let's left click on one of these faces and create a new sketch. We're going to create two circles that are symmetric across the y-axis. So let's do that first. Put our symmetry constraint in. It also makes them collinear. Let's set the dimension of both of these so that they're the same. And we'll set the dimension to 2.8, which is, of course, the minor diameter of the PT screws that we're using to assemble our robot with. And our offset reference is going to be from the top of the mounting boss here. So we will give that an offset of 3 millimeters. And we need to center our hole in the boss here. So let's give this an offset of 4 millimeters. We'll center it perfectly. All right, so with that, we have added our two mount points. So we can close out of the Sketcher workbench, and we will pocket this all the way through our mounting bosses. So there we are. We can see that we're all the way through. And the next thing that we're going to do is we're going to mirror our part. Actually, we're going to add some fillets here first. These are cosmetic, but we did the same thing with the battery box, so we're going to maintain that aesthetic continuity across all of our parts. So I'm just holding down the control key because I'm using the Blender key set. Give that a fillet of 2 millimeters. And let's grab these 3 lines on the top of our mounting bosses. And we'll also fillet those to 2 millimeters. All right, so now that we've got that, now let's mirror this part. So from the tree view, left click on the body, and we're going to choose the mirror tool. We want to select our reference plane for this mirroring operation, so we're going to left click on this one here, and we'll press OK. So here is our mirrored shape. And now we're going to add some the rectangular tabs on the top of our enclosure box. Now these rectangular tabs are not symmetric across the x-axis because our rear cover is going to have a gap in it for the switch panel that we're going to add. We're going to do that in the next episode. So let's add 3 rectangles. And of course, we're going to make sure that they all have the same vertical length and they all have the same horizontal width. And we're going to make sure that they are all collinear. So we're going to select a corner in each one of them and constrain them vertically. We're going to grab some construction geometry now, and we're going to put a construction line between our rectangles. Let's set the construction lines so that they're equal to each other. And now I'm ready to start adding some dimensional constraints. So I'm going to actually clear away some of this clutter here. I'm going to turn off all the constraint markers that we have already in place. And now I'm going to set the length of this construction line to 5 millimeters. I'm going to set the vertical length of our tab to 10.2 millimeters. Let's set the width of our tabs now to 3.2 millimeters. And so now our tabs move as a group. Our 2 degrees of freedom are the location for this group along the X and Y axis. So let's reference the edge of the enclosure top. And we're going to give it an offset of 2.9 millimeters. And I'm actually going to clear away that view here. And I'm also going to reference this bottom line here. And I'm going to set its offset from the bottom. Right here, we're just making it so it's easier to see the different constraint markers there for you. So 9.15 millimeters is the bottom constraint. And so with that, we have fully constrained our tab sockets. So let's close out of the Sketch workbench. And let's pocket those all the way through. And we need to add one anchor point. We want to make sure that the rear panel can't just fall out of its tabs. The way we've designed it would make it really hard. But this is just one additional anchor point. This will be a screw that ensures that the back panel can't fall off of the rear of the enclosure. So we're going to set this anchor point to a diameter of 2.8 millimeters. And we're going to use the top of the mounting boss here as our reference. So let's give it an offset from this point of 25 millimeters. And then we're going to give it a horizontal offset of 8 millimeters. Okay, so that is our anchor point, and we'll add a boss to the rear panel there. That's our anchor point fully secured and constrained, so we can close out of this and pocket it all the way through our shape. And that completes the top cover for our Vetronics enclosure. By utilizing the tab and socket architecture, our panels are now locked perfectly parallel when we assemble them. And in the next video, we're going to design the back cover, which will be split between the portion of the back cover that sits over top of the Arduino Uno and the panel that holds the switch. Chart your course, build your world. I'll see you in the next one.